What if I told you there's a train racing beneath the ocean? Not through a tunnel floating underwater, but through solid rock buried deep below the seabed. Above it, thousands of massive cargo ships carry goods across one of the busiest shipping routes on Earth. Below them, passengers are checking their phones, drinking coffee, and barely realizing they're surrounded by millions of tons of seawater. It sounds impossible, yet this is exactly what China is building. Deep beneath the East China Sea, engineers are creating one of the most ambitious transportation projects ever attempted. A high-speed railway tunnel stretching more than 16 kilometers, with over 11 kilometers running directly beneath the ocean floor. Trains will travel at speeds of 250 kilometers per hour through a passage hidden nearly 80 meters below the surface. But the tunnel itself isn't what has engineers around the world talking. It's how China is building it. The machines digging this tunnel are so enormous they look like moving factories. They have to travel for kilometers through unpredictable rock and soil before meeting each other underground with almost unbelievable precision. If they're even a few centimeters off target, years of work and billions of dollars could be lost. And when those machines finally complete their mission, they'll never come back. Instead, they'll be left buried beneath the ocean forever. Today, we're diving inside one of the world's most fascinating engineering projects to discover why China believes this tunnel is only the beginning, and why many experts think it's preparing for something far bigger. Before we get into that, make sure to subscribe if you enjoy videos about incredible engineering, mega projects, and the technology shaping our future. Now, let's start with the question that began this entire project. An island that outgrew its connections. Off China's eastern coastline lies Zhoushan, a group of beautiful islands surrounded by busy shipping routes and rich fishing waters. Millions of tourists visit every year, attracted by the scenery, seafood, and coastal lifestyle. At the same time, the islands have become an important center for ports, heavy industry, and international trade. But despite their growing importance, one major problem remained. Getting there wasn't easy. For decades, people traveling between Ningbo on the mainland and Zhoushan depended on ferries or long drives across bridges. Ferries were often delayed by rough seas and bad weather. Road traffic became increasingly congested as more people and businesses moved into the region. For tourists, it meant wasted hours. For businesses, it meant slower deliveries. For an economy moving at incredible speed, it became a serious bottleneck. China had already spent years transforming transportation across the country. High-speed rail networks connected cities that once felt days apart. Trains regularly crossed mountains through tunnels and glided over enormous bridges stretching across rivers and valleys. But the ocean remained one of the last major obstacles. Bridges seemed like the obvious answer, until engineers looked closer. This stretch of water isn't just busy, it's one of the most active shipping corridors in the region. Even then, bridges have another weakness: nature. Strong winds, powerful storms, dense fog, and salty sea air constantly attack structures exposed above the water. Maintenance becomes expensive, traffic can be interrupted, and severe weather always remains a risk. A tunnel changes everything. Hidden beneath the seabed, trains can operate regardless of storms above. Ships continue sailing freely without worrying about bridge clearance. It was the perfect solution, at least on paper. Actually building a tunnel beneath the ocean is a completely different challenge. Unlike digging through a mountain, engineers couldn't predict what they would encounter below the seabed. Every kilometer could reveal different layers of granite, clay, sand, fractured rock, or water-bearing ground. Any mistake could allow seawater to rush inside under tremendous pressure. This wasn't simply another tunnel. It was one of the most difficult environments imaginable for underground construction. Yet China decided to go ahead anyway. To accomplish it, they needed machines unlike anything most people have ever seen. These weren't ordinary drilling machines. They were moving engineering giants weighing thousands of tons, designed to eat their way through the earth itself. And what these monsters are capable of is where this story becomes truly unbelievable. Building a tunnel beneath the ocean isn't something you can do with ordinary construction equipment. Blasting with explosives is far too dangerous, especially when you're working beneath millions of tons of seawater. Engineers needed a method that was not only powerful but also incredibly controlled. That's why China turned to two of the largest tunnel boring machines ever built. Named Dinghai and Yongzhou, these machines are engineering giants. Each one stretches about 150 meters long, roughly the length of 1.5 football fields, and weighs close to 4,000 tons. At the front is a rotating cutter head nearly 15 meters in diameter, fitted with dozens of heavy-duty cutting tools designed to crush solid rock instead of blasting it apart. But the cutter head is only the beginning. As it slowly grinds through the seabed, a massive conveyor system carries the broken rock out through the back of the machine. At the same time, another system begins assembling the tunnel itself. Giant precast concrete segments are lifted into position and locked together to form a complete ring around the newly excavated section. Once the ring is in place, grout is injected into the space between the concrete lining and the surrounding ground, sealing every gap and reinforcing the tunnel against the enormous pressure outside. In other words, the tunnel is being built only a few meters behind the cutter head. By the time the machine moves forward, it leaves behind a fully supported section of railway tunnel instead of an empty hole. Throughout the project, operators have to respond to nearly 30 major geological transitions, constantly adjusting pressure, cutter speed, and advance rate to match whatever lies ahead. To deal with these conditions, the tunnel boring machines were heavily customized before construction even began. Engineers added advanced water injection systems to prevent sticky clay from clogging the cutter head, strengthened critical components to withstand the immense pressure beneath the seabed, and upgraded the drive system so the machines could continue operating reliably for months with minimal interruption. Instead of starting from one side and digging all the way across, China launched 2 tunnel boring machines at opposite ends of the project. Yongzhou began its journey from the mainland near Ningbo, while Dingai started from Zhoushan Island. Working simultaneously, both machines have been carving their way toward the same meeting point hidden deep beneath the seabed. On paper, the idea sounds efficient. In reality, it's one of the greatest precision challenges in modern engineering. Each machine must travel for several kilometers through solid rock without ever seeing the other. If either one drifts off course by even a tiny amount at the beginning, that small error grows larger with every meter they advance. By the time they reach the middle, they could miss each other completely. Imagine spending years digging 2 separate tunnels beneath the ocean only to discover they don't connect. That single possibility meant engineers needed a way to guide these massive machines with astonishing accuracy. And to do that, they had to rely on technology that begins far above the tunnel itself, in space. A tiny error at the beginning, something almost impossible to notice, could eventually place you several meters away from your intended destination. Underground, that would mean the 2 tunnels would completely miss each other. If that happened, the consequences would be catastrophic. Years of excavation, billions of dollars in construction costs, and one of China's most ambitious infrastructure projects could end with 2 separate tunnels that never connect. Correcting an error like that beneath the ocean would be incredibly difficult, expensive, and time-consuming. That's why precision became just as important as power. To achieve it, engineers relied on one of China's most advanced navigation systems, the Beidou Satellite Navigation System. Similar in purpose to GPS, Beidou provides highly accurate positioning across the globe. But satellites alone aren't accurate enough for a project like this. Normal satellite navigation can be off by several meters, which is perfectly acceptable when you're driving a car but completely unacceptable when you're trying to connect 2 underground tunnels. So the engineers developed something far more sophisticated. Before excavation began, they established an extremely precise survey network on the surface using satellite positioning, laser measurements, and fixed reference points. Those measurements were then transferred underground through a series of shafts and control stations. Inside the tunnel, advanced guidance systems constantly monitored the position, direction, and angle of each tunnel boring machine. Every few moments, the machines compared their actual position with the planned alignment. If the cutter head drifted even slightly to one side, the guidance system immediately detected the error. Hydraulic steering cylinders would then make tiny corrections, often so small they were measured in millimeters. These continuous adjustments kept both machines following exactly the same invisible line beneath the seabed. But connecting the tunnels created an entirely new problem. The boring machines had finally completed their mission. There was just one issue: they were trapped. Each machine weighed around 4,000 tons and sat deep beneath the ocean floor with no way to move forward and no practical way to reverse out through the tunnel it had just built. So what do you do with one of the largest construction machines ever built when its job is finished? Surprisingly, you don't bring it home. Most construction equipment finishes a project the same way it begins it. Once the work is done, it's transported to the next job site. Tunnel boring machines don't have that luxury. When Dingai and Yongzhou finally broke through and connected the 2 ends of the Gintang Undersea Tunnel, they had reached the end of their journey. The problem was that each machine was sitting deep beneath the seabed with no practical way to leave. Moving forward wasn't possible because there was no more tunnel to excavate. Reversing wasn't a realistic option either. So instead of trying to recover the machines intact, engineers chose a far more practical solution. They dismantled them. This process is known in the tunneling industry as shedding the shell. Once excavation is complete, teams of engineers begin taking the machine apart from the inside. The cutter motors, hydraulic pumps, electrical systems, control equipment, sensors, and other valuable components are carefully removed piece by piece. These parts are transported back through the completed tunnel and can later be refurbished and reused on future projects. It's a slow and meticulous operation. Anything that can be used again is given a second life. But one part of the machine never leaves. The massive outer steel shield, the enormous cylindrical structure that protected the machine during excavation, remains exactly where it stopped. Rather than treating it as abandoned equipment, engineers make it part of the tunnel itself. The steel shell becomes permanently embedded within the structure, adding another layer of reinforcement around one of the tunnel's most critical sections. In effect, the machine doesn't simply build the tunnel. It becomes part of it. It's a remarkable example of engineering efficiency. Instead of spending huge amounts of time and money trying to remove thousands of tons of steel from beneath the ocean, the structure is simply incorporated into the final design. The machine completes its mission, and then quietly stays there forever. Long after passengers begin traveling through the tunnel, most of them will never realize they're passing through sections where parts of the original tunnel boring machines are still hidden behind layers of concrete and steel. It's almost poetic in an engineering sense. These machines are built for one purpose, and once that purpose is fulfilled, they become part of the very infrastructure they were designed to create. With the excavation complete, however, the project is still far from finished. A tunnel carved through solid rock isn't ready for trains the moment the digging ends. Now begins an entirely different phase of construction. According to the current construction schedule, the excavation is expected to be completed by the end of 2026, followed by extensive interior work over the next couple of years. If everything proceeds as planned, high-speed trains will begin operating through the tunnel in 2028. When that day arrives, the journey between Ningbo and Zhoushan will be cut from more than an hour to roughly 30 minutes. For commuters, it means less time traveling. A project designed not only to connect an island, but to prove that China now possesses the technology, experience, and confidence to build something far more ambitious. Because if engineers can successfully construct an 11-kilometer railway tunnel beneath the seabed, the obvious question becomes, what's stopping them from building one that's 10 times longer? As technology continues to advance, tunnels beneath oceans may one day become as common as bridges are today. If that happens, projects like the Gintang Undersea Tunnel won't just be remembered for connecting two cities, they'll be remembered as the moment engineers proved that even the ocean is no longer an obstacle.